answers, okay? So let's look at how we can do the first question here. Alright, students, let's look at this first question here, which is on solving is on discriminant, A math, additional mathematics. So given that negative half to 5 is a solution for this inequality, so where A, B, C are positive integers, find the value of A, B, C. Now, just bear in mind that there are actually multiple answers to this question. You don't really need to, there's no exact value for A, B, C. I mean, there are just many solutions, many solutions. But the idea is the same. So the thing now is essentially what they're saying is working backwards, right? Because you're told that actually, if you were to solve this, okay, let's say this is, the solution set here is minus half to 5. And if you are looking at this half of the inequality x, so the question now is, what should your A, B, C be? This quadratic equation here, that which gives you less than 0 here. All right, that is the question. So what we need to do is actually just expand this part here. This part, obviously, we know that we could have x plus half as a root, as a factor here. So x plus half as a factor, and this is a quadratic curve of x minus 5. This is one possible equation. So this is x plus half, and x minus 5. And this would be less than 0, right? Between this region here, because you are looking at this to here, over here. So once this is done, I think this is pretty okay. What you could do is just x squared. Just expand this part here, x squared minus 5, x plus half, x minus 5 over 2. Okay. Now the thing now is, because this is these are all positive integers. So A, B, C are integers. Integers are numbers, whole numbers, like 1, 2, 3, 4, 5. They have to be whole numbers. So this case here, if you were to just key in calculator, you realize that this would not give you a integer. It's actually a fraction here, so we wouldn't want that. We are going to just put this as x minus 5 over 2 less than 0. So what you're going to do here is actually just multiply by 2. Now, you don't have to multiply by 2. You can actually multiply by 4, or any even number, you'll get any values there. So actually, ABC you can have many values, okay? So you could multiplying by 2, I would presume that would be the standard answer. But you could multiply by any other thing. So this is 2x squared minus 9x minus 5 less than 0, okay? So this case here, it could be A equals to 2, B equals to minus 9, and C equals to minus 5. Am I right? Okay, so this is one way of doing it. If you wouldn't want that to be the case, you could actually multiply by 4 as well. So multiplying by 4. So this will be, this is one possible answer. Okay, you could multiply by 4 if you want to. So meaning to say, I just multiply both sides by 4, and this would just be, this will be 4x squared minus 18x minus 10 less than 0. So the answer here, it could also be A equals to 4, B equals to minus 18, and C equals to minus 10. Okay, now there are many multiple answers which you can give, right? So this is just one. So this is how you do this question here proficiently. Any question at all, please let us know, and I will see you in the next question. Hi students, let's look at this question here, which is on discriminant. Let's see how we can do this proficiently. So the first one is find the range of value of k for which the quadratic function has real roots, right? So you're told to find this for real roots. What we're going to do is actually just move the k squared there. So this is k squared x squared. This is a quadratic function here. So 2x minus kx plus 1. The thing is, because I need this to be 0, real roots just means that you have these quadratic curve have to cut through the x-axis. Okay, it has to, and this will be a smiley face because k squared is definitely a positive number. But I don't think that really matters, but we will look at that. So this is 2 plus k. This is x plus 1 equals to 0. Okay, so for the equation to have real roots, for equation to have real roots, okay, we know that the discriminant, which is b squared minus 4ac, has to be more than or equal to 0. Okay, you can real root would also mean that it could cut once, right? It just means that. So this case here, okay, minus 2 plus k square, and I just hope that there's no careless mistake there. So this is plus, okay, just be very mindful of the bracket, and minus 4k square, which is a, c, which is 1 less than 0. Okay, so that's how you do this. Okay, so I would suggest, okay, just square it and don't try and expand it, because I can see that this is a difference. You could just do this, and this will be quite nice. So this is a square minus b square. So what you can do is 2 plus k. Try not to expand. I typically tell my students that expanded form is less superior than the factorized form, because in the factorized form you could actually see what's going on. Yeah. Then this part here will just be 2 minus k, and this will just be 2 plus 3k. And there you go. We could actually solve this portion here as real roots. Okay, great. So real roots, there you go. So I'm just gonna solve this part here. And I will get, this is a set phase. K is a positive number, is it? K is a positive real roots. This would just be a set phase here. Okay, because minus k. Just be careful, minus k, and after which this will just be negative 3 over 2, and this will be 2. We want it to be positive, so this will be here. So hence k will just be equals negative 3 over 2 and 2 here. Okay, so what does this mean on the graph? Let me just sketch on Desmos for you, and you can have a look at how does it. Sorry, there's a mistake there. I realized that I wrote it wrongly. So this would just be this is actually k equals negative 3 over 2. Is it? Or negative 2 over 3, and that will be negative 3 over 2. So what does this would show? The reason why I know that I did a mistake is because I just sketched it on a Desmos curve. Now this is the curve. This is the curve that you look like, okay? When you bring this over, so I just plot this curve in this side here. This is the curve that we're looking at. Now what we need is actually, this is the line here, which is cuts once or cuts twice, right? What we need here is actually, as you could see, that as you vary k, it will just looks differently like that. So when you, what we go through is actually we want this, which is cuts once the x-axis, and twice here, and after which it becomes a linear equation. The reason why it becomes a linear equation is because k is nearing 0, and when it's 0, it becomes a linear line, right? So it's still a real root there. Yeah, that's how you understand and visualize this. So this is how you do this questionnaire proficiently. Any question or comments, please do let us know, and I'll see you in the next question. Hi students, let's look at this question here, which is on discriminant. Let's see how we can do this proficiently. So find the value of a and b for which the solution set x squared, ax less than b is between negative 2 and x. So let's look at that. Okay, I'm going to just move the b over to the other side like that, right? If you have a solution set for this equation here from minus 2 to 4, and this is actually, this quadratic equation here is actually less than 0. So meaning we are looking at this portion here, right? So great. Now once this is established, we just try and understand that this, you have many solutions to this. So this could be y equals to x plus 2, x minus 4. Okay, but this is the basic one. So meaning you just by looking at this equation here, we are looking at this solution set here, right? And what we need is actually try to expand and just compare, right? So this solution here is actually telling us that this y equation is less than 0 because it's below the line y-axis here, the x-axis here. So when you expand this, I think shouldn't be too bad. Expanding it will be just minus 8. So very quickly you could tell that a is equal to minus 2 and minus b is equal to minus 8, right? By comparing. So just by comparing this and this, so let me just compare x squared plus ax. It's just working backwards. I think that's pretty okay. So by comparing the coefficients. Okay, we have this. So basically, once this is done, we have A equals to -2 and B equals to 8. That's how we do this question here proficiently. Let's look at the second one. So we are told that we have got this equation is only satisfied by this portion here. So I think the same thing. It's exactly the same. So I'm going to bring the bx to the other side and maybe just move this around. Yeah, and I know that this is a smiley face, so I'm just going to draw this equation out. And the solution set is from -2, anything less than -2, and also more than 3, right? So from this graph alone, we know that we are looking at x plus 2. This equation here would be y equals to x plus 2, x minus. This is E-math, right, where we talk about quadratic equation. And the solution that we are looking at is actually anything, the curve is more than the x-axis here. So we are looking at this solution here. Alright, now what we're going to do is the same thing as the first part, which is to compare and contrast. This is x squared minus x minus 6 more than 0. That's pretty okay. So once you're done with this, expanding this is fine. And what we're going to do is look at this carefully. This is a 2. So we don't have a 2 in front. What we're going to do is just multiply by 2 here. Because if you need to compare, you just need to make sure that some of the coefficient have to be the same. This is 2x minus 12 bigger than 0. Okay, so by multiplying by 2, so then you compare the curve here. So hence, minus b equals to -2 and a equals to -12. So hence a is -12 and b is 2. Okay, that's how I do this question here proficiently. Any question at all, please let us know and keep practicing. I'll see you in the next question. Students, thanks for watching our weekly live stream. So I would encourage you to actually, if you want to learn more, you could just sign up for our free online course on our website. So just go to free online mini course where we just go through some of the basic principles, like some of these topics here. So you could actually consider, if you really like our online courses, you could actually access the whole curriculum by just getting the full access course for our online courses. Our online courses are in a way where you have what do you call it? Full all access to Sec 1 to Sec 4, let's say the E-math course and also the A-math mathematics course. So the exciting thing is that our student dashboard, which you could see here, our student dashboard where you could have all access to E-math courses and also the A-math courses here. Apart from that, we are building a question bank also in the community section. You can actually post your questions there and our teachers will actually take time to answer your question. And all this is just at a very minimal cost of $20 a month. Okay, so if you have any question at all, please let us know. And I am very happy to see you next week. Bye.